the Hadamard gate followed by Hadamard gate, which is an example of interference. What this means is I actually show some the quantum composer. So when I have just one, how do I disable the video? Okay, on my side. For the first quantum gate, let me. I probably should also change to just one gate. So when I just apply one Hadamard gate on the first qubit. Oh, hello. Someone cannot hear me? Hello?
I can hear you just fine.
Okay.
All right, thank you. It's basically it was an issue on my side. Thank you so much.
Sure. Yeah. Okay. Yeah. Okay. Good. So when I just apply first Hadamard gate, so we have a superposition. Now, if I apply the second Hadamard superposition, it goes back to just 0, 100% to the original state. So this is the example of the interference. So this here is why that's the case. So apparently, if we apply the Hadamard gate twice, it's basically become the identity transformation. So I guess mathematically that's the case. When we go dig, when we explain in more detail, and we will find this is also an example of a quantum interference. So we can verify Hadamard gate applied twice is identity transformation just by multiply. Oh, Justin is coming. Sorry. I apologize. I should turn off my phone before class. Okay, sorry. So if we apply the Hadamard gate twice, we can elaborate this. Will be the first one will be 1, right? The second one will be this part, which will be 1 times 1 minus 1 times 1, which is 0. Right. So, how do I remove the? I just realized that
It will be easier, I think, if you distribute 1 over square root of 2 first and then multiply.
Yeah.
You get it after that.
Yeah. I'll just this one will be actually 1 minus 1 is 0, and this one should be it's also 1 minus 1.
Yeah, it will be 0.
Yeah. This one is 1 plus 1. Sorry. The bottom will be. It's also 1. The 1 plus 1. So bottom will be 1 times 1 plus minus 1 times minus 1 equal 2, actually. So this will become the matrix of which is the identity matrix. Oops, there. So there. So basically, that's how the mathematically that makes sense. It's on the side. So, but there's also more meaning on this. So we can actually write it in a different way to show why this is the interference. So let me try to explain why this is an example of interference. So first, the example is when we if we apply the Hadamard gate on the first H0, when we apply it on the H0, cat 0, H cat 0, we will have a superposition. Superposition, which is the cat 1. So when the first step is superposition. This is the first one, first time. The second time, if we do that, we're basically going to do add the Hadamard gate on the superpositioned Hadamard gate of that. And this will, we can basically expand this. So that basically is the above. Right, so that's not that basically is this part. And so basically expand that. Hadamard gate on this cat 0 plus cat 1. I'm sorry, 1. Larger processes. Okay, so then this basically become this is cat 0 again. So plus the cat 1. So basically now we have two terms. The first term is just what we started with. Right? The first term is just what we just did. And now, but this time we have a second term, which is not cat 0, is actually apply Hadamard gate on cat 1 now. The second term is a bit different. It turns out, well, the first term we already know. We already know the first term will be, it's yellow. Which is what? Cat 0 plus cat 1. That's the first term, the yellow part. This is the yellow part. Now, the second term, it turns out that part, if we expand that, that will be in the form of a it's a cat 0, but the second term of this expansion is actually negative cat 1. And we can actually use the linear algebra later on to find out. So that's actually there. This is the second term. So if we put these two terms and then we will see I guess the canceled out term will be canceled out. So that's this the cat of 1, the first one is a plus, the second one is a negative, and these two terms are canceled out. But cat 0 will be is actually also interference, but amplified. How do I change that? This will be a positive amplified, I guess. This will be so the cat 1 will be cancelled out, but cat 0 will be amplified, and then what we have in now is basically twice. I'll just okay. Maybe I just said twice. And this basically is cat 0. So there. So the reason we kind of found out why the Hadamard gate on cat 1 is negative sign. So more on that one. So why Hadamard gate on cat 1 is minus cat 1. So and in this part we can just expand it out. So the Hadamard gate on cat 1. Well, Hadamard gate is what? Minus 1. And what is cat 1? Cat 1, the first bit 0 is 0. Second bit 1 is 1. So that's cat 1. And we basically can just expand this out. We found, so that's 1. The first term is 1. The second term is minus 1. So the first term will be, oops, sorry, highlighted. First term will be 1 times 1 plus 1 times 0 plus 1 plus 1. So that's 1. The first term is 1. But the 1 over square 2 there. And the second term will be, let's see, So 1 plus 0 is 0, minus 1 plus 1 is minus 1, sorry. So minus 1. So we have the minus 1 there. So there you see that's where the negative sign came from. And what is this? This is basically the first bit is a 0, second bit is 1. So this basically is, oops, yellow. Cat 0 minus cat 1. Yeah, so there, that is why we have this negative 1 here. So this is, so if you actually Google or do some other reading, you find that 2 consecutive Hadamard gate is one of the simplistic example of quantum interference. So there, this is why. And we can actually go back to the IBM quantum composer to actually see this. So if we remove the first gate, remove the second gate, right, initially it started with the 0. Right, so and then we add Hadamard gate. Now we have superposition with the north cat 0 and the south cat 1 superposition of this, and then we add another Hadamard gate there. It goes back to the north, 100% to the north. So this is this is this is a very good example of quantum interference. So
does it continue to interfere if you keep adding Hadamard gates, or does it just stabilize here?
Well, if you add, just repeat everything. Good question. We can try.
Yeah.
Sure.
Interesting.
Yeah. I mean, it goes to the original state as if nothing happened. So, yeah. So, interesting suggestion, though.
Yeah.
So, yeah. Okay. Yeah. So it's interference. Goes back to the original state. Interference goes back to, I guess, as if everything restarted every day. Like a Groundhog Day, Yeah.
That's funny.
Yeah. So yeah. Okay. Now this is for the comparison. This is the consecutive quantum gate on a single qubit. Remember, there's another case we discussed, which is the Hadamard gate applied in parallel on 2 qubit. So yeah, if we apply that on 2 qubit, that's still superposition, and it's also not entangled. So we may I forgot, but let's just explain this as a comparison with a consecutive one. So then we will have the so it's actually also a good exercise to prepare you to do the homework assignment on that